And let me hand you over to Team MIYAROR².
Hi, hello, thank you very much. So we are Team MIYAROR². I'm Tim, we've got Nicola, Rick and Stuart. And when we came up with this idea then, I'll go through it in a moment for you, we had an absolute pain trying to come up with something that was actually right, because everything we did was either far too easy or far too hard. So we found this Goldilocks thing that's just right. Now, what we have created is an interactive smart mirror. So smart mirrors are a thing that are around. It's essentially putting an LCD screen and a mirror together so you can get the information all in one place. When we were first thinking of something to do, one of the biggest bits of inspiration we were kind of thinking of at the time was, what's in sci-fi that we don't have yet? And it's not normally a good thing to go to a dystopian future to look for the kind of tech you should go for. But Black Mirror worked really well. So I was always fascinated by the idea of all the stuff that they did on here, and this was one that I personally, when I first saw it, was like, that's amazing. I'm a super forgetful person. I say that right here and now. I've got a smartwatch on because it runs my life for me. In the mornings, I don't even have that because I'm still up getting ready, and I'll forget everything. And I was thinking, well, what if we could have that, but what about all the other people in my house? So we were trying to think of a way of, well, how could, Nicola use it after I'd used it? Because all my data is going to be there. And that's when we thought about putting in facial recognition technology. So this is what we've ended up with, which is this lovely facial recognition mirror. We're going to run a little demo video for you, and Rick's going to explain some things. And then hopefully, weather permitting, we'll do a live demo, and we'll see how it goes.
Okay, so as you'll see in a moment, when somebody approaches the mirror is already constantly checking for a face. It does that with concept with the back end, which will be explained in a moment. But as soon as it finds somebody, it sends the name back to the front end, and the front end then checks on the device for what's stored on there for that particular person. All those bits of information are then taken off and sent off to different APIs, and then that's then populated on the screen. And it creates obviously a personalised experience for each person. As soon as somebody walks away, it recognises that somebody's walked away, and then it resets back to the clock so all that personal information isn't shown again.
Half the time I don't know what day it is, so...
Okay, so now I hand over to Nick and Tim, who can show you a quick demo of the mirror.
Yep, so here's part of the fun bit. Normally, your camera would be this lovely thing located here, but obviously if we do this, you're not going to see anything. So what we've done is we've got the camera externally done here, and I'm going to mirror the page on here as well. So this shows you what the mirror is showing, but a little bit better if you can't see because of this lovely reflective screen that's here. You're upside down. There we go. So it's recognized Nicola's being in front of the mirror and starts bringing up her information. So I'm going to grab that off of her, and she will explain what's going on.
So each screen is personalised, and everyone chooses their own information. That's saying good afternoon, Tim, so it's a personalised greeting. We've got the local weather in his area. We've got a route to work and how long it takes to get here. I described this as a fun fact today, but it's just facts because there was something about a king dying before and it was not fun. So it's a fact about what's happened on this day sometime. But see, not a fun fact. Obviously, the football team of your choice, the mighty Wigan Athletic, and just news headlines for that day. And Rick will just talk through the tech stack.
So the tech stack we use for this, for the front end, we were using React. And, I'll start with the back end. Back end, we use CMake, Node.js, Express, and dlib. Now, it's probably worth mentioning that CMake is a C++ library that had to sit outside of the of Node. And for the front end, as I say, we used React mainly, and CSS and HTML, obviously. Testing, we used Mocha, Chai, and Supertest.
Just a little bit going deeper into the machine learning aspect of it. Once the image is sent and it hits the Express endpoint, it's going to start building to this library. So I'd like to say that I built a whole machine learning algorithm myself. I didn't. Robbed off the internet. Face recognition.js uses dlib, which is a whole bunch of packages. That's the one that's in C++, and it has a Node.js wrapper around it. What it's doing is using cool stuff to detect the boundaries of a face, add landmarks to points on the face, like the nose, the brows, and then creates a model which stores distances in n-dimensional space between all of these points. We feed it a bunch of images when we first register a user. That's used to train a model. And then what you saw there is for a user that's already been registered, an image gets sent, the model gets loaded up, it gets compared. If we get a match that's within a certain tolerance, something will be relayed back. So, for example, like Ant, who's not here, looks quite a lot like Jesse Eisenberg. But if Ant was in Jesse Eisenberg's house or the other way around and they tried to hack each other's mirrors, it wouldn't work because the tolerances of this are quite specific. So that's not going to work. And that's it for that stuff. Oh, also carpentry, because this is a hardware project, and the real MVP is Rick right now. I mean, you have to go to like Swoon or John Lewis to get something like that. Look at that. He's sanded it and everything. It's really nice. So, and like we said, yeah, the Raspberry Pi element of this was quite challenging, but we'll come to that at the end of the kind of things that we do differently.
We made a conscious decision to just store the information in local storage using React, mainly because we didn't need a database for the information that we were storing. It was first names, it wasn't complex, and it wasn't a lot of information, so we kind of agreed that that's how we would store the information. What we expected when we originally started the project, that this would be a massive front-end project with a little bit of back-end and obviously some testing alongside. What actually happened was it was a big back-end project with the facial recognition being very important. And that's how it ended up. We solved that problem. We had daily stand-ups. We communicated that with each other, and we used the Kanban board. So we were able to just carry on with our back-end, and we managed to get everything finished that we wanted to in time. Another issue that we had was the APIs that we wanted to choose. We wanted people to be able to use Facebook and Twitter and get those on the mirror. They would not let us have API keys. So what we ended up having was something. It looked the way we wanted it to, but it wasn't. We could have, if we had more money, we could have done more with it, I think. That's what we agreed.
Yeah. So sort of going back and looking, we just sort of skip past. We had these very grand designs. We were like, oh, we can pump all sorts of data into it. And then the more we started looking at the more security-conscious data, the more we were like, oh, we can pump kind of data from it maybe at times when they don't block our API. So we decided to sort of strip away the ones that were giving us problems, and for now just focus on the ones that would kind of give you that initial functionality, give us that kind of proof of concept, and still look impressive and be useful for you.
It seems to be quite a lot of trying to lock down third-party applications and unauthorized use of data sharing, but that seems to have happened practically in the middle of project phase. Changes to Twitter APIs to get rid of unauthorized apps that now don't work, clearing out bot accounts, which is obviously good for keeping our data safe, but not as much when you want to just spin up a cool app and chuck a bunch of third-party applications that you can authenticate and then get displayed to the user. But the concept remains exactly the same.
And with hindsight, now obviously we've done the projects, we wouldn't have done a massive amount differently, to be honest with you. One thing we definitely would have looked at first is putting on a motion sensor and having a TV with a HDMI connection. If we had chosen that at the beginning, the motion sensor could have switched off the monitor when it wasn't being used, and obviously that would have been a bit more consumer friendly. Also, we could have used a motion sensor to take photos and to trigger that initial action, rather than having a recursive function at doing that. And we have been playing around with voice recognition as well. The Google Home is working, but unfortunately we didn't have a chance to tie that in with any of the functionality on the mirror itself, although it does work. It can tell you a joke, but that's about it.
So the one thing that we sort of skip past that we're going to talk about now is Raspberry Pi. So for those who don't know, it's basically like this lovely little breadboard computer. It's a fantastic little thing. And what we wanted was our lovely mirror here to be a kind of self-contained unit. And at the end of the day, that's still what we designed for. The more eagle-eyed among you will notice the laptop, which is definitely not a Raspberry Pi. So the mistake we kind of made is we got this Raspberry Pi, we connected up the cameras to it, it was fantastic. Day one, got it out of the box, got this camera working, and we thought, isn't this amazing? Isn't this a fantastic piece of technology? Let's put it in this box and not look at it for a week while we make the code. So
Pretty much. Yeah, pretty much.
the mistake there was that when we got it back out the box a week later, and we were like, oh, look at this lovely piece of technology, let's turn it all on. And why doesn't it know what the camera is anymore? And then we thought, oh, don't worry, we'll plug a USB web camera in. Why doesn't it know what any camera is? And we couldn't really get over that hurdle, and unfortunately that hurdle happened last night. So it's still something that we would do. Like, we would still put this as a Raspberry Pi project, but we definitely learned that if you're designing something for a specific piece of technology, don't assume that because it worked the first time out the box, it's going to magically work again, because technology likes to not do that.
Hopefully it's captured your imagination, if not your wallets. So, yeah, thank you very much.
Cheers.